Solve the system of 4 equations. Okay, whenever we have a system like that, it's usually nice to put it in matrix form. It actually helps us solve it faster if we can use a computer. So let's rewrite this by aligning each column that has C1. So we'll leave a space for C2 for this first equation. Then we have C3 here, and then we have plus 2C4. And we know that all of that is equal to negative 17. Okay, so now let's write the second one. We don't have anything for C1, so we'll just put 0 C1, and I'll do the same here for C2, plus 0 C2. And for C2, we have plus 3 C2, then we have minus 2 C3, and then we have minus 3 C4. All of that is equal to 58. Then we have a third one right here with 2C1 plus 3C2 plus 0C3. You see how it does not appear? 0C3 is like adding 0. And plus 4C4. And all of that is equal to negative 1. Well, now we have one more. It's this one. And we have 6C1 plus 3C2 plus 5C3 and then plus 0 C4. We don't have a C4. And all of that is equal to negative 5. Now that we do that, we realize that we can rewrite this as a coefficient matrix, which is going to be 1, which is going to have all the coefficients in front of the C's, 2, and then 0, 3, negative 2, negative 3, and then we have 2, 3, 0, 4, and finally we have 6, 3, 5, and 0. Then a vector with C1, C2, C3, and C4. And all of that is going to be equal to the vector negative 17, 58, negative 1, negative 5. Now we realize that really the information that we need is this and this. This doesn't really matter. This just tells us later what the solution can be or has to be in order for the statement to be true. So we can actually devise an augmented matrix 1, 0, minus 1, 2, and 0, 3, minus 2, negative 3, and 2, 3, 0, and 4, and finally 6, 3, 5, and 0. Okay, forgetting that I'm augmenting this and I'm putting the results here. Negative 17, 58, negative 1, and negative 5. Then, if I put this in MATLAB, and you'll see that in the next video, or in part B of this video, what I get is the identity matrix. So it's a 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1, because it was a 4 by 4, right? So this is what you get for an identity matrix of a 4 by 4. And I'm saying this was a 4 by 4. And now I keep closing it out of habit, but actually we got something on the right as well. We got negative 421 over 75. Then we got 299 over 25. Then we got negative 36 over 25. And then we got negative 481 over 75. And you close this right here. And Now, if I were to write it back as this, then I would know, if you want to see the full step, you would have this matrix 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Now I would actually close it. And then back you'd have C1, C2, C3, C4. And on the other side, you would have a negative 421 over 75. I probably need to write it like this. Negative 421 over 75. And 299 over 25, negative 36 over 25, and negative 481 over 75. And now that you have this, what's going to happen is if you execute the multiplication, you're going to get that C1 equals negative 421 over 75, C2 equals to 299 over 25, C3 equals negative 36 over 25, and C4 equals to negative 481 over 75. They were asking us to solve the system of 4 equations, and we just did that. So now we can write the result. C1 is equal to negative 421 over 75. C2 is equal to 299 over 25. C3 is equal to negative 36 over 25. And C4 equals to negative 481 over 75. And to see how we were able to get this result from MATLAB, look at part 2. See you in part 2. Part B, actually.